Hello there, pre-calc students. This is Mrs. Weihe speaking. I know you're probably more familiar with hearing Mr. Plocker's voice on these flip videos, but it's my turn to kind of take a crack at it here with this Unit 4. So Unit 4 is about polynomials and rational functions. Now for this first lesson, we're just going to be kind of divulging into polynomial functions. Now when you think of polynomial, you probably think of, you can kind of pick on that word poly. So you might think of different things in math, such as like a polygon. That would be one example. But when we think of polynomial and functions, polynomial functions, that's just about kind of having multiple terms. We're going to have kind of multiple chunks in our function instead of our traditional. Maybe things that we've encountered just as like a regular y equals amx or mx plus b. Or our maybe quadratic functions. So here we'll have multiple terms. Now, here are some terms to remember, some vocab that I want you to be thinking about throughout this lesson. We'll encounter this continually throughout this unit. So just here are some things that maybe you want to write down in your notes to kind of pay attention to. We already discussed a little bit just what a polynomial function is, but we'll be learning about what a degree and leading coefficient, how to pick those out and how to determine that, along with the zeros and roots of a function. We'll also be encountering the fundamental theorem of algebra. You guys are probably familiar with that word theorem and probably encounter that in geometry a little bit, but here we'll be talking about this fundamental theorem of algebra and how that relates to our polynomial functions. And we'll also be learning about factors of function, how to find those, and really what that does. Now if we turn to our first example, f of x equals x cubed minus 6x squared plus 10x minus 8. The first thing we want to do is find this degree. You're probably familiar with degree. Yeah, so we're thinking about this degree. You're probably more familiar with this degree when you think of the temperature outside. Seeing that degree symbol, such as an example of 78 degrees Fahrenheit. So we're going to apply the same logic of seeing this degree up here. We can apply that same idea and that same concept to our function here. So here our degree is actually going to be our exponent. And it's actually going to be the greatest exponent of the variable. So here greatest we mean the largest term. So here it would be that 3, that x cubed. So our degree for this function, or for this equation, would be 3. When we think of leading a coefficient, this is going to be that coefficient that's kind of tacked on right there with our variable that has the highest degree. Here that leading coefficient, or that number that would be in front, would be 1. Now when we think of roots, we want to think about it's the solution for the polynomial equation. So think of roots is really our solution. Now sometimes the word solution and roots, roots and zeros sometimes are used interchangeably when discussed. But technically you find the zero of a function and the root of an equation. And we'll go through different examples throughout this unit. Now, some of it you might see in your assignment card. You might actually see, it might ask you to determine if, for example, 4 is a zero of f of x. Now to determine that, we would plug in f of 4. Now as you recall, when we do that, all we're doing for x is we're just plugging in 4. So it'd be 4 cubed minus 6 times 4 squared plus 10x, or 10 times 4, minus 8. 4 cubed would actually be 64. 4 squared is 16 times 6 is actually 96, plus 40 minus 8, and we add that all together, we actually get 0. So it is true that 4 is a zero of f of x. When you think about, now when we think about this fundamental theorem of algebra, what it states is it states that any polynomial of degree n has n roots. So now, for example, if we have, just like in our previous slide, that degree was 3, so that polynomial would actually have 3 roots. Now, sometimes this might get a little bit tricky because some of these roots might be imaginary. Now, I know you've encountered imaginary numbers before in previous math classes, but we'll have some more practice here today throughout this lesson, but also in class in our assignment cards. So now, for example, when we graph some of these polynomials, we'd have a degree 3 with one real 0. That's one of these first examples. Now, when we think of real 0, that's just where it crosses that x-axis. So here, it's degree 3, where you can see degree is really where the slope changes. See how it changes here 3 times? And that one real 0, as we stated before, is going to be right at the x-axis. So you continue to look through these different examples and see such as like degree 5 with 5 real zeros. Here, all of that roots would actually be real and cross the x-axis all 5 times. Now, an example that you'll see throughout your assignment card and possibly on our test would be to write a polynomial equation of least degree with roots 2, 4i, and negative 4i. Now here we just initially we want to start off right away by writing down what our roots are. Here they already gave them to us, but it would be 2, 4i, and negative 4i. Now I want to make this connection between roots and factors. These two things kind of play off of each other. When we think of factors, you probably heard about that when we've been doing foiling or a factor tree. You've probably encountered that word multiple times throughout your time as a mathematician. But here factors, when we are talking about factors and roots, our factors really are x minus our root. So here some of our factors for our polynomial equation would be x minus 2, x minus 4i, and here since it would be x minus a negative 4i, it would really actually be x plus 4i. And here once again, these i's are our imaginary numbers. Now to write the polynomial equation, what we actually want to do is we want to multiply all 3 of these factors together. Now see, this is where I'm talking about, we're kind of doing that reverse of foiling. So here if we want to start off right away, let's kind of get our imaginary numbers out of the way. So initially we'd have x minus 2. Now we'd have x squared. Then we'd have minus a 16i squared. That's kind of, if you work through a little bit of that math just a little bit, you have that x squared minus that 16i squared. Now recall that when we have an I squared, what does that do? Having that I squared, that just turns it to a negative number, like a negative 1 is all that I squared would turn into. So it would actually just be x minus 2 times x squared plus 16. And then we can kind of do the foiling again. Once we do that, we'll actually have x cubed minus 2x squared plus 16x minus 32 equals 0. So here, the polynomial equation with roots 2, 4i, and negative 4i would be this x cubed minus 2x squared plus 16x minus 32. So this is actually our polynomial equation. Now another example that you might encounter is when they'd ask you to find the number of complex roots of the equation. Here it would be 9t to the 4 minus 35t squared minus 4 equals 0. Then they might want you to find the roots and graph the function. So here we can see that it's a degree of 4, so that means, just like our fundamental theorem of algebra, that we would have 4 roots. So here there's 4 complex roots. So we can state 4 complex roots. Now, we want to factor the equation to find the roots. So, taking 9t to the 4 minus 35t squared minus 4. To factor this, sometimes it might just take some trial and error to really come up with a solution. But after you tinker around maybe just a little bit, and we'll have plenty of practice with this in class and in our peer reviews and on your assignment card. But it would be 9x